Hello friends, so today in this video we are going to talk about heat exchangers. Okay, so first of all let us see what is the definition of heat exchanger. So this is the basic definition of heat exchanger. A heat exchanger may be defined as an equipment which transfers the energy from a hot fluid to a cold fluid with the maximum heat transfer rate. So there are two pipes in contact with each other, okay, like this, and one contains hot water and another contains cold water. Now what happens when they both of them come in contact with each other? Then they transfer heat occurs from hot to cold. Okay, so this is the process of heat exchanger. Now we'll see several types of heat exchangers. Some examples of heat exchangers are first of all you can say intercooler or preheaters. You have seen them, intercoolers and preheaters, or second condensers or boilers. Okay, so these are some examples. Okay, condensers and evaporators, automobile radiators, oil coolers, okay, milk pasteurizers, etc, etc. Okay, so now let's see types of evaporator. Okay, so this is the important part of the video. Types of evaporator, types of types of heat exchanger, sorry, type of heat exchanger. Okay, heat exchanger. Well, there are several types of heat exchangers, so we will discuss only important. So heat exchangers are classified on the basis of, first of all, the nature of heat exchange process. Heat exchange process. Second one, it is defined on the basis of the relative direction of fluid flow. Relative direction of fluid flow. And third one is on the basis of design and construction features. Okay, so design and constructional features. But in this video we will discuss only about the relative direction of heat flow, okay, of fluid flow. So this one, relative direction of fluid flow, is categorized under three categories. First one is parallel flow, or unidirectional flow, okay, because it is flowing single direction, unidirectional flow. Second one is counterflow, it is in opposite direction to each other, okay. And third one is cross flow. Of the three of them, counterflow is most effective, okay. You'll see in the same video that how is it more effective than the other ones. So in parallel flow heat exchanger, what happens, the fluid stream, hot and cold, both the streams flow in the same direction, okay. So it is like this. Suppose this is a hot pipe, okay, in which hot fluid is running, hot stream or hot pipe, okay, hot stream, and it is surrounded by two cold streams, okay. This one is cold and this one also is cold, okay. So what happens, fluid flows in the same direction, okay. So hot fluid enters, so the hot fluid TH and this is T cold, both enters at the highest temperatures and the lowest temperatures, and when it goes out of this pipe, and what happens, they attain some temperature, the hot and the colder fluid get hotter and the hotter fluid get cooled, okay. So this is the function of parallel flow heat exchanger. We can draw a graph to understand this, okay. So suppose this is a graph. Say the temperature of a cold fluid in is TCI and cold fluid out is TCO. Similarly, hot fluid in is THI and hot fluid out is THO. Now what happens when the temperature is higher? So then entry at the entry temperature would be higher, so TH in would be higher and TCI would be at the lower temperature, because TCI is lower. This is the temperature scale. Now what happens when they move forward, okay, the fluid moves forward, then what happens, hotter fluid get cooled, hotter fluid get cooled and cooler fluid gets hotter, so the temperature will rise, okay. So temperature rises, and similarly for the hotter fluid, temperature decreases, falls down. So the final temperature will be THO, that will be lower than THI. So here THI is greater than THO, and similarly this TCO, so TCO would be greater than TCO. So this is the function, this is the working in the parallel flow heat exchanger. After understanding both the counterflow and the parallel flow heat exchanger, we'll discuss about its advantages and disadvantages. Okay, stay tuned. So in counterflow heat exchanger, what happens? Suppose this one is the water pipe. Okay, now hot fluid is running this and cold fluid is running this. Now hot fluid is surrounded by two cold streams. Okay, so what happens in this? Streams flow in the opposite directions. Suppose hot fluid run in this direction, then what will happen? Cold fluid run in this direction. So due to this reason, it is more effective than the parallel flow. You will understand this better when I'll explain it with one easy example. Okay, so let's see the graph. Okay, so graph would be something like this. Say the this is the THO, this is THI, TCI, TCI, TCO. Cold fluid out, cold fluid in. Now the temperature for the hot fluid will be higher, so THI will be higher, and when its temperature decreases, then it will be something like this, THO. Now here temperature TCI, temperature. Suppose one more thing, that hot fluid is running this direction and cold fluid is running in this direction. Now what will happen? The THI would be at the left side and TCO would be the right side. Sorry, in the left side. Okay, so what will happen? The THI would be at the higher temperature, THO is the lower temperature. Again here TCI is going inside from the right side, so the graph will start from this side. So TCI, now when it moves forward, then its temperature rises. Okay, when temperature rises, then it will graph will be something like this. So this is TCO, and this is the working for the counterflow heat exchanger. Now we'll understand how counterflow heat exchangers are better than parallel flow heat exchangers. Okay, so there are several reasons behind that why it is better than the parallel flow heat exchanger. First one is it have larger value of LMTD. Okay, this is logarithmic. First one LMTD, it has the larger value of this. So this is LMTD is logarithmic mean temperature difference. Mean temperature difference. So the advantage of having a larger value of LMTD is that it permits a small heat exchanger area A0. Okay, for a given heat exchanger Q, it would result in smaller and less expensive equipment for the given application. So it would be cheaper and it would be less bulkier or smaller in size. Now second point is it have greater potential energy recovery. Then what is it? It have greater potential energy recovery. Here in counterflow heat exchanger, we can see that hot stream may be cooled up to the temperature TCI. Okay, so hot fluid may be cooled up to temperature TCI. So this is the reason why it have higher value of or greater potential energy recovery value. Okay, so it could lose maximum heat and it could allow other fluid to get heater or hotter. Okay, so this is the main advantage of using counterflow heat exchanger. But in the case of parallel flow heat exchanger, we can see that cold fluid and hot fluid, okay, both are almost at the same temperature, but the the colder fluid getting the higher temperature, and due to that reason it would not have the higher or greater potential energy recovery value. So due to that reason it would be not that much effective as much counterflow heat exchanger is. Now let us see few applications of parallel flow heat exchangers. Now in parallel flow heat exchangers, where they are used, wherever there is high initial heating rate is required, we could use parallel flow heat exchanger, because we can see that at the initial positions, high temperature is at its elevation and cold fluid is at its lowest point. Okay, now what happens when they both enter at the same stand, then maximum heat transfer would be occur. Okay, so here one term is also introduced, that is exergy and energy. Okay, this one is available energy and this is unavailable energy. Then there is a large amount of loss of available energy, and the energy is lost to the cold fluid. Due to that reason, it transfers a lot of heat to cold fluid, and due to that reason, we could use this in heating of very viscous fluids. Parallel flow provides for rapid initial heating, and consequently, it decreases the fluid viscosity. And due to that reason, could use it for the places where pumping is required. And if we use some other fluid which have high viscosity, then it is not easy to pump. But if we heat the fluid, or if we make it at lower but if we heat the material like wax or paraffin, then we could easily decrease its viscosity, and by decreasing the viscosity, it is easy to pump it. Okay, so it reduces the pump effort. Now another example for this, first one was, so where high initial heating rate is required, so it is used for pumping high viscous fluids. Now the second point is, so where it is required, the temperature development at the tube walls are moderate. So suppose in this barrel flow heat exchanger, what happens, hot fluid enters at a high temperature, cold fluid enters at a lower temperature. When it flows in this, and what happens, the temperature gets at the moderate temperature is obtained. So due to that reason, the walls do not get heated a lot. Okay, so where it is required to be a moderate temperature of the walls, then at those places we use parallel flow heat exchangers. And there is one more profit of having that, is there is small amount of scaling scales. Okay, scales, and falling is also reduced. So these are the two disadvantages of heating water or any other fluids in, or these are the two effects of which destroys or harms to the pipes. Okay, so where there where it is, where the tubes are sensitive to falling effect, we use parallel flow heat exchangers.